Dear learners, I welcome you all to this online teaching session. Today, in Practical 4, we will discuss about estimation of paracetamol and diclofenac sodium using simultaneous equation method by UV spectrophotometer. So, aim to estimate percentage weight by weight of paracetamol and diclofenac sodium in given tablet using simultaneous equation method by UV spectrophotometry. Reagents and chemicals required are standard paracetamol powder, standard diclofenac sodium, paracetamol and diclofenac sodium containing tablets, zero point 0.1 normal sodium hydroxide, and distilled water to prepare zero point 0.1 normal sodium hydroxide. Apparatus, volumetric flask of different sizes, pipettes, beaker, and funnel. You also require Wattman filter paper for filtration of standard as well as sample solution, and tissue paper for wiping off outer surface of cuvette. You require UV spectrophotometer for uh, carrying out analysis, and high precision weighing balance for weighing of samples as well as standards. This slide depicts API profiles, paracetamol, diclofenac sodium, molecular formula, molecular mass, melting point, uh, CAS number, IUPAC number, and uses. To start with preparation of standard solutions. So you have to prepare a standard solution of paracetamol as well as diclofenac sodium. To prepare a standard solution of paracetamol, 5 milligram of paracetamol is weighed and transferred to 50 ml volumetric flask, and small volume of zero point 0.1 normal NaOH is added to dissolve paracetamol, and volume was made up to the mark with 0.1 normal NaOH to get 100 ppm solution containing paracetamol. From above solution, 1 ml solution is taken and diluted, dilute up to 10 ml with 0.1 normal NaOH to get 10 ppm paracetamol solution. In similar way, diclofenac sodium solution is prepared by dissolving 5 mg of diclofenac sodium in 50 ml of 0.1 normal NaOH to get 100 ppm solution containing diclofenac. From that, 1 ml solution is taken and diluted up to 10 ml to get 10 ppm diclofenac sodium solution. While preparation of solution, sonication is required, and after preparation of solution, 100 ppm solution, both the solutions are filtered through Wattman filter paper, and then further dilution is done. The sample is a tablet containing diclofenac sodium and paracetamol. 20 tablets are taken, average weight is calculated. The average weight of the tablet is 637 milligram, which contains 50 milligram of diclofenac sodium and 325 milligram of paracetamol. The tablets are triturated to get fine powder. Now, preparation of sample solution. As we know that the average weight of the tablet is 637 milligram, so which contains 50 milligram of diclofenac sodium. So for 50 milligram of diclofenac sodium, you require 637 milligram of tablet powder. So for 10 milligram diclofenac sodium, you require X milligram of tablet powder. So what is the X? Means for 10 milligram of diclofenac sodium, how much quantity of tablet powder is required. So X is 10 into 637 upon 50 is equal to 127.4 milligram of tablet powder is taken, and it is transferred to 100 ml volumetric flask. Small volume of NaOH is added, 0.1 normal NaOH is added. The solution is sonicated for 5 minutes. Then make a solution was diluted up to the 100 ml mark with 0.1 normal NaOH. Again, the sonication is done for ensuring or to ensure complete dissolution of drug into the solvent. Then the solution is filtered. From the filtered solution, 2 ppm solution is prepared by diluting 0.2 ml of this 100 ppm solution to 10 ml up to 10 ml. So you will get 2 ppm solution of diclofenac sodium. And we know that our tablet contains not only diclofenac sodium but paracetamol. So in this 10 ml solution, how much paracetamol, how much quantity of paracetamol is there, that we should know. So for that, the calculation is 637 milligram of tablet powder is equal to 325. It contains 325 milligram of paracetamol. So we weighed 127.4 milligram of tablet powder. It contains how much paracetamol? So Y is 325 into 127.4 divided by 637, which comes to 65 milligram of paracetamol. So that means that when 127.4 milligram of tablet powder was weighed to get 10 milligram of diclofenac sodium, at the same time 65 milligram of paracetamol was also there in that tablet powder, and we dissolved it into 100 ml NaOH. So 65 milligram of paracetamol dissolved in 100 ml, that comes to 650 ppm, that is 650 microgram per ml. And further we did dilution, means 0.2 ml was diluted to 10 ml. So when this dilution is done, the final concentration of paracetamol is 13 ppm. If you calculate, you will get the reading or the value 13 ppm. That means the sample solution contains 10 ppm of 2 ppm of diclofenac sodium and 13 ppm of paracetamol. Now we have three solutions with us. 10 ppm diclofenac sodium solution standard, then standard paracetamol solution 10 ppm, and sample solution containing 2 ppm of diclofenac sodium and 13 ppm of paracetamol. So to start with, as we know that for simultaneous equation, in simultaneous equation method we require 2 lambda, that is lambda max of both the components. The components are diclofenac sodium and paracetamol. So first step is to get lambda max of both the solution. So both the solutions are individually scanned using 0.1 normal NaOH as a blank from 200 to 400 nanometer, and the lambda max is obtained. Lambda max. So here we have taken lambda 1 as a lambda max of diclofenac sodium and lambda 2 as a lambda max of paracetamol. And diclofenac sodium is our X and paracetamol is our Y. Now at these two wavelengths, the absorbance of diclofenac sodium is taken, and also the absorbance of paracetamol solution is taken to get AX1, AX2, AY1 and AY2. So these two solutions, in short, these two solutions are measured at both the wavelengths and absorptivity is calculated for both the compounds for both the wavelengths. Now coming to sample solution, this sample solution is measured at lambda 1 and lambda 2 and absorbance are recorded. The absorbance at lambda 1 is A1 and absorbance at lambda 2 is A2. Now calculation part. So here the lambda 1 is absorption maxima or lambda max of diclofenac sodium solution, and lambda 2 is the lambda max of paracetamol solution. Diclofenac is our x and paracetamol is our y. So when the absorbance of 10 ppm diclofenac sodium was taken at both the wavelength, the using this absorbance absorptivity is calculated. Similarly, for paracetamol, that is Y, absorptivity at both the wavelengths is absorptivity at both the wavelength is measured, and sample you have to take absorbance for at both the wavelengths. How will you calculate absorptivity? The formula is A is equal to ABC, where A is absorbance, small a is absorptivity, B is a path length which is 1, and C is a concentration in gram per 100 ml. So let us take one example how absorptivity is calculated. So suppose diclofenac sodium X is giving at lambda 1, it is giving 0.280 reading. So how the absorptivity is calculated? So as A is equal to ABC, small a will be equal to capital A by BC. Now A is our absorbance 0.280 upon 1 is a path length and concentration of diclofenac sodium. The concentration was 10 ppm. This 10 ppm we have to convert into gram per 100 ml. This is very important. To calculate absorptivity, the concentration should be expressed in gram per 100 ml. So the absorptivity will be 28. Similarly, you can calculate absorptivity for paracetamol and for both the wavelengths. The value which you are getting for all the standard and sample solution, you have to substitute those values into the equation. So you will get the concentration of X and concentration of Y. X is our diclofenac sodium and Y is our paracetamol. And very important, the value you will get in gram per 100 ml. The concentration will be expressed in gram per 100 ml, because for calculation of absorptivity we had used the unit gram per 100 ml. So again the concentration which you get after solving this equation, you should convert it into ppm. So suppose Cx is 1.8 ppm and Cy is 12.1 ppm. So how will you find out percentage purity? 2 ppm was our theoretical value, because in this sample solution the diclofenac concentration was 2 ppm. So this is our theoretical value, and paracetamol was 13 ppm. So 2 ppm is 100%. So suppose you get the value by experiment 1.8 ppm. So 1.8 ppm will be how much percentage? So that comes to 90%. Similarly, you can calculate for paracetamol. 13 ppm is 100%. So 12.1 ppm which we obtain by performing the experiment is how much percent? So that comes to 93.07%. Result you can describe the result as the given tablet sample contains 93.07% of paracetamol, because this is our paracetamol, and 90% of diclofenac sodium. Thank you for patiently listening. Have a good day.